Hello everyone, I'm here to show you demo on classify all test and plot confusion 90% accuracy. Basically what this function does, it demonstrate using a model that gave me 98% accuracy on all test data, and using this network how will we plot a confusion matrix. So initially what it does, it loads all the train data into xtrain and its corresponding levels in ytrain, then loads all the test data in xtest, then its level in ytest, then it loads the network, then we'll visualize the convolution layers and the fully connected network, then we'll based on this train network will estimate the classes of the test data and we'll keep it an estimated class variable. Now based on the this predicted class and the actual class of the test files, we'll plot a confusion matrix. Okay, so here we go. Now we'll run this function. Okay, this is a demo of using the model that gave me 90% accuracy. However, if you want, you can also use other models that give 96% accuracy or the 94% model accuracy, but I would say that don't use the 94% accuracy because its accuracy, as you can see, it's less than 96 and 98. You'll see it in the report, and also that time consumption is very high. So if you want to use the 96% accuracy to just to demonstrate, you can use the other function. So it should just write, instead of writing 98, you write 96. Okay, so now we'll demonstrate for this function. Now when I call this, it will take a lot of time because initially it loads all the data, all the train and test data, and the dimension of xtrain is very high because in 7 different actions, in each of the actions there are 8,000 train images. So 8,000 into 7, total 56,000 train images, and the dimension of each image is 100 cross 100 cross 1. So the dimension of this xtrain variable will be 100 cross 100 cross 1, that is dimension of one image, into the total number of images, that is 56,000. So overall the dimension of xtrain will be 100 cross 100 cross 1 into 56,000, and 56,000 are there, so 50,000 different labels will be there. Each image has one label. Okay, so that will be 56,000 cross 1. So, and for test data, I said in the report that there are 40 images in each action folder. So therefore the dimension of X test will be 100 cross 100 cross 1 into 280, and for Y test, that is the labels for test, it will be 280 cross 1. So it's still running on. What is visualization? Although it's not asked in the project, but I have used visualization. So what is visualization? Visualization is nothing but how we can visualize the learned network in the form of pictorial form. That is, in simple words, based on the while training whatever filter weights that each convolution layers fully contained network, the neurons of fully contained network learns. We can visualize these layers in pictorial form. Okay, I think the load data already completed. Now it is working on the visualization part of each of the convolution layers. So in 90% accuracy model, there in total there are 3 convolution layers. Okay, so I have I have visualized for demonstration, I have visualized all the 3 convolution layers and the last fully connected layers. Okay, it's now working on the first completed, second convolution completed, third also completed, and now we are working on the last fully connected network. It's working. Okay, let's see now. Okay, not the confusion. Okay, fine. Okay, so coming to the results, what we got so far by running this program. So this is the visualization of my first convolution layers. As mentioned in the reports, total there are 13 filters in the first convolution layer. So you can see there are 30 small tiles. You can see, right? And these tiles are arranged in like for the first filter or first convolution layer is this one, then second, then comes third, fourth, fifth, sixth, then it goes to the next row, sixth, oh sorry, seventh, eighth, ninth, 10th, 11th, 12th, hence it goes on till 30. So there are 6 into 5, 30. Now coming to visualization for this is the visualization for second convolution layer. In second convolution layer there are 20 filters. This is the first, second, third, fourth, fifth, sixth, seventh, eighth, all arranged small tiles from left to right, then top to bottom. Then comes this is the visualization for third convolution layer. For the third convolution layer there are 10 filters. So 10 small tiles, 1 2 3 4 5 6 7 8 9 10, and these are nothing. These are nothing. So we'll only consider till this part, only this part. Okay, so starting from 1 2 3 4, then 8 9 10, that's it till here. And for the last fully connected network, in last fully connected network, as there as in this project we need to classify 7 different actions for the, so for the last fully connected network I have defined the number of neurons to be 7. So there are 7 tiles, 1 2 3 6, then 7. And lastly the end result, that is the confusion matrix what I got. So this is the confusion matrix. So I have got an accuracy of 98.2%, you can see, and the diagonal elements are the number of elements that are correctly classified. This is the level of the actual class, this is the level of the predicted class or estimated class, whatever you want to say. So for the first action 38 have been correctly classified, all 2 of them are misclassified. For the second action all of them are correctly classified, third also same, fourth also same, fifth only 1 wrongly classified, then for the sixth 2 misclassified, and for the last also all of them are correctly classified. So that's it. You can run the same demo for this function also. And one thing, for this function I have skipped the training part because this is just a demonstration how will we use the train network to uh, plot confusion matrix. There is also I have also defined a comprehensive function that starts from training until to visualization until we plot confusion matrix. So this is it. So this function you can run, but mind it, if you run this function I might not guarantee whether you get an accuracy of 98% or not, because you need to, while running this function, I mean particularly in the training part, you need to keep an observation on like how much is your mini batch loss or mini batch accuracy, then validation accuracy. Based on that you have to also set number of epochs. And in other words, if you use this function it will create a new train network. Okay, and and in that network its weights and its biases may not be same as the one I got it over here. Similarly you might not get the accuracy as same as uh, you got over here, even though you use the same training data and test data. So that's it. Thank you.